All right, today we're going to dive into something really cool, the playbook for teaching science to young minds. This isn't just about facts and figures, It's about lighting that little spark of curiosity that can seriously last a lifetime. So, let's just jump right in with a question.
Seriously, take a second. How would you actually prove to a kid that a plant is alive? I mean, it doesn't run around, it doesn't talk. It sounds so simple, right? But this question, it gets right to the heart of all the challenges and honestly the brilliant strategies behind great science education for kids.
Okay, so let's get into this challenge. Because getting science right in those early years, well, it's absolutely crucial. But it's also where you run into some of the biggest hurdles.
Elementary school is so much more than just learning the ABCs. It's the super foundational period. It's where a child's entire relationship with science can be forged. A really positive, engaging experience here can build the whole framework for curiosity and that kind of critical thinking that really powers STEM fields for decades to come.
And this right here, this is such a huge point. Teaching isn't just about adding new information. A massive part of the job is actually correcting these ideas that feel really intuitive, but are, well, wrong. A kid looks at a plant and thinks, it doesn't move like I do, so it can't be alive. The real challenge for an educator is to get ahead of that thought and gently start to rewire it before it becomes this permanent mental block.
So, when you're facing these kinds of challenges, what's the game plan? Well, luckily there's a playbook, a really solid set of core principles that can guide anyone trying to teach science effectively to young kids.
And it really boils down to this three-part strategy, and all the parts work together so well. First, you've got to encourage abstract thinking. Help kids connect ideas beyond just the stuff they can see and touch. Second, you make it real with hands-on methods, turning those big ideas into actual concrete experiences. And third, like we just talked about, you have to be on the lookout for those common misconceptions and tackle them head-on. Each step just builds right on the last, creating this amazing foundation for real understanding, not just memorizing stuff for a test.
Okay, so theory is one thing, right? But let's see how this playbook actually shakes out in the real world. We're going to break down a script for a science video called Are We Alive? Just to see these principles in action.
So check out this first piece of evidence from the script. Notice how it handles the idea of movement. It doesn't just state a fact, like living things move. No, it totally anticipates what the child is thinking, that plants don't really move, and it meets them right there with this fantastic bit of phrasing.
And that's the genius of it, isn't it? It's all in the wording. By saying, even if it's very slowly, and then giving that awesome example of a plant turning towards the sun, the script cleverly just expands the whole definition of movement for a child. It's a perfect example of proactively taking on a misunderstanding. It's not just correcting, it's completely reframing.
All right, next up, the script tackles another one of those big abstract ideas that all living things have needs to survive. But instead of just giving them this dry scientific list, it grounds the whole concept in something every single kid understands on a gut level. It connects it right to their own life.
And that just brilliantly shows off that second principle. It takes this huge scientific concept of biological needs and makes it personal, makes it concrete. I mean, every kid gets needing lunch to have enough energy to go play. By creating that simple link, the abstract idea just suddenly clicks. It makes sense.
And this whole idea leads us straight into that super powerful hands-on principle. It's all about learning by doing, by watching and experiencing. It's the difference between someone telling you a seed grows and you actually watching it happen with your own two eyes.
The video script uses this amazing tool to kind of simulate a hands-on experience, a story. Leo's little seed isn't just some cute little tale. No, it's a narrative that walks you through the scientific process. Leo observes, he gives the seed what it needs, and he gets to see the result. It turns a boring list of characteristics, growing, needing water, into this really engaging journey of discovery.
So, when we put all these pieces together, what's the big picture here? What does this kind of approach actually accomplish in the long run?
Well, it shows us that great science teaching isn't an accident. It's a deliberate, thoughtful strategy. It's about using things kids can relate to make these big, complex ideas feel simple. It's understanding that clearing up confusion is just as important as giving out facts. And at the end of the day, the real goal isn't for kids to just memorize what makes something alive. The real goal is to make them so curious that they just never, ever stop asking questions.
And that kind of leaves us with one last thing to think about. Think about something complicated in your own world, maybe at work or just something you're trying to explain to a friend. How could you make it understandable, make it relatable, and how could you get ahead of the common misunderstandings? Turns out, the playbook for young scientists might just have the answers we're all looking for.